ConnectED Techers, I know you've missed us. We've missed you too. But hey, 'tis the season for a new season. It is season 3, episode 1, Elizabeth. Let's give ourselves a pat on the back for making it this far. Even though it's been a while since we pushed out an episode, we are back with a vengeance. We're so excited with what we have planned and in store for all of you all.
I feel like you're not excited enough, Darryl.
I am excited. I'm gonna rip off my pajamas. Look, Christmas pajamas. Look how cute we are.
We are so cute.
We didn't plan this at all.
Not at all.
Oh, we did. It was a Christmas episode.
How could we plan it at all? We're in a Zoom call here. You're way over there. I'm way over here. How could we have possibly planned that?
I don't know. I scream really loud sometimes. Like, Elizabeth, can you hear me? From miles and miles and miles away with this whole social distancing.
I know. I'm over it. I'm just glad we don't have to wear masks on Zoom calls.
I know. So the CDC says you can't transmit COVID over the internet.
That's what they say, but you never know. All right.
Okay, don't start that conspiracy theory. Okay, it's all in the 5G is what they say.
That's what we don't need. Another conspiracy theory.
No, we don't. And talking to us about conspiracy theory, who do we? I'm just kidding.
It's all a conspiracy. I'm really excited to see you, Darryl. It's been too long.
It's been too long since what? When was that last episode?
We recorded back in July with Josh, our good friend from GimKit. And since July, lots of things have happened, and 2020 has been a bizarro year, right?
Absolutely.
It's been bizarro world, not like we ever thought it would be. But you've had some personal changes in your life, right?
I did. I got a haircut.
God, it looks great.
Thank you.
New PJs and a haircut.
I know. I haven't gotten a haircut in like 8 months. So no.
It was time.
Besides the haircut, most importantly, we have a little baby, my wife and I, Olivia. Baby Olivia.
Cutest little baby.
I know. You can't tell. I've been getting lots of sleep and lots of coffee. So here we are on what's today? Saturday.
Yeah, I love when you talk about the baby. It always sounds like you are the mother of this child with all the struggles that it is being, going through the labor. It was so hard. I got no sleep at the hospital. It was just so tired. It was your wife, Darryl, who did the work, the main work.
Yes, but I was there.
Well, speaking of the hospital, you were there, and I was also there, kind of.
Uh-huh.
Tell me that story. That was a great story.
Oh my gosh. And that was a crazy time leading up to TCCA, which we love. We go to TCCA, present there every year, but we had the honor of being a featured presenters. Yeah.
We got to pay them still. We haven't.
It's like, please put our name out there.
Pick us.
And we picked up 5 subscribers, which is good for us. But anyway,
I think we did.
So it was October, right? It was the
24th, I think.
24th, right? And my wife's due date was supposed to be November 8th, a day after her birthday. But baby Olivia decided to come the day before TCCA. So I was like, oh snap, Elizabeth, I'm tagging you. Got to do all 4 of those sessions on your own. But you had a great idea. It's like, why don't you do it from the hospital rooms? We have internet, and
if Sabrina's okay with it,
that's true. If Sabrina's okay with it, and of course, yes, she was, because she knew how much we were excited about it, and we made it happen in the hospital room with Olivia and my wife to the right, and all the nurses coming in. And I believe there was a part during the session where I think Olivia was getting her first bath, and she was crying in the background. But it made the whole event so special. It's a day I'll never forget because my daughter was born, but presented at TCCA while in the hospital room. And man, the folks at Aldine ISD, man, they've been great, and they even sent us little gifts afterwards congratulating us on our newly born child. So it was great. It's always great experience TCCA, and then sharing it with you, Elizabeth, being so flexible with everything. And we had some pretty.
I didn't have a choice, Darryl. I didn't have a choice. It's like I could say, "Hey, Sabrina, push that baby back in, okay?" Many years, and we love hearing all the stories of the cool things that they're doing in their classrooms and the way that they're learning and they're sharing their learning. And we decided that for our first couple of episodes of this new season 3, instead of going back to our ed tech friends that are out there presenting at all conferences, we would just go to the trenches, to the front lines, and ask some of these teachers and students to come on and be our guests at the very
I know. That's what came on my. If this is going on YouTube, they're gonna like flag
I
it.
know.
But if we sing it off tune,
yeah,
they'll keep it on there.
Anyway, be our guest. And we got some takers when we asked, and we were so excited because our first 2 guests are actually high school seniors at Darryl's school, at his campus.
Yeah, they're seniors, and we've known them for quite a while. It's kind of sad to see them go, but they're gonna do great things, and we're gonna introduce them in a little bit, and they're gonna tell us their stories of how we met, and I'm telling everyone, you're in for a treat. Like, we've been inspired by these kiddos since the day we met them. Totally. And I'm gonna be honest, my Google journey to become a trainer, an educator, and an innovator started from one of the students here, because he actually got certified before me, and he convinced me to do it, and I did it. Very happy, very proud of what we've been through with the whole Google training certificate and all that good stuff. So yeah, these kids, they've inspired me, and they've inspired me to do coding, which we'll talk about more in a second. But
I have to say the same thing, and then we'll take a short break and come back and introduce our friends. But the inspiration is so true, because that same kid who inspired you to go ahead and get that certification didn't know that you were going to inspire me and probably a whole lot of other peoples to get their people to get their certifications. But he also inspired me to use the new version of Google Sites for the very first time, because I hadn't actually, I'd used the old classic version for a while, and then he had used the new version for a project at school, and I saw what he had done with it, and I'm like, I need to do it. And I have made so many Google Sites for so many different purposes, and it all started with the inspiration from a student who was in middle school at the time. So, all right, let's take a short break, and we'll be right back.
It's a Flippin' Improv Con with your hosts, Elizabeth and Darryl. You don't want to miss this live virtual improv on the fly style PD event hosted by Flippin' Good Tech. We will be bringing back many of our podcast guests for the first ever in the history of all things, confirmed in a quick Google search, ImprovidCon, where the E and D most definitely stand for Elizabeth and Darryl.
You're absolutely right about that one, Darryl. There will be banter, there will be laughter, and you guessed it, there will be llamas. So make plans right now to spend your Saturday morning with us and some of the greatest names in ed tech. January 16th, 2021 from 9 to 11:30 a.m. Central Standard Time. You can register today at flippinggoodtech.com and make sure to follow us on all social media platforms. We are everywhere.
And we're back. Thanks for sticking around after a commercial break. And we tell you, you're in for a treat. You're going to see these names on the next...
Probably some obscure research paper.
No, it'll be like Times Most Influential People of 2030. I kid you not.
We'll be in the honorable mentions for everybody else.
Hey, that's still great to be an honorable mention. Okay. I'm trying to butter up the audience, Jonathan and Adam. So we've got Jonathan Chacko and Adam Wynn with us. And like I said, you're in for a treat. We're in for a treat.
You keep saying treats, and now I want treats. Darryl, do you have treats?
That's all I have. It's all in the script. You see all the word treats. I have treats like underlined 30 million times.
Lots of treats. They're like the young Zuckerberg.
There you go.
And what's the
Larry
other guy?
Larry Page and
I like
Sergey
Larry
Brin.
Page better.
Yeah, Larry Page and Sergey Brin. There you go.
Younger versions right here. Younger, better versions.
No, but I was telling before our break how Jonathan, you've inspired me to get certified, Google Education certified, level 1, level 2, because you got it before me and you convinced me to get it, so I did it, and then it progressed to be getting my trainer and innovator. This is going great so far.
Jonathan is an influencer.
Definitely
an influencer. Not even a joke.
But man, I'm telling you, like we're so excited to have you on the show, and we're excited for what's going to happen, what's in store for you all, because right now you're in the midst of applying for colleges. And actually, I wrote a couple of your recommendations, so if you get into that college, you're welcome. If not, it wasn't my fault. But yeah, we're excited for what you have in store for your future. But
what I love, can I say one thing too about them, is that what I love about them is that they are such models for what we really want our students to, like the preparation we want them to have when they are seniors in high school and they're ready to launch into that college or that career that they're about to go into. We want them to be in a place where they feel like they've had some successes, that they've had some experiences where they've been able to do some problem solving and solve those problems and then work the kinks out to be able to produce something that they can feel proud of, that they feel proud of, but they can also use to help other people. And I feel like they're already doing those things. And I'm excited about this interview with them because later we're going to get into some questions for them where they're really going to tell us about how they're using those skills specifically to do things to make an impact on their campuses with students and teachers that they're working with now. But first, we have an interesting little challenge for them.
Yes,
interesting little challenge because they're coding gurus.
Coding gurus.
Yeah. They like that better than wizards.
The coding wizards. I mean, you're a wizard, Harry.
Coding sorcerers?
Not that much better, but it's all right.
So this is, it's kind of reminiscent of, if I don't know if anyone's out there familiar with UIL computer science, they're given these challenges and they have to, code in Java like on the spot. So this is on the spot, right? No, you've had about what, 15, 20 minutes? We told you about 15, 20 minutes ago, this challenge. So we have
I mean, most of that time was like, the solution to this challenge, very similar to one that I solved a couple of years ago. So the actual solution, it was like, took us like probably 30 seconds to come up with, but like explaining it all out to that's what takes time.
Perfect. So you could have just came up with this and solved it like that. But since we have an audience here and we kind of want you to, our audience out there, to be in the minds of these students and how they decipher a problem and break it down into parts and actually solve it using code. Okay, we're talking about computational thinking and all that jazz. So I guess our goal here is to make sure that, don't be intimidated by computer science and programming, because computational thinking can be used throughout any type of subject area that you're teaching. So we're just going to dive in the minds of Adam and Jonathan for a second here. So we're going to show you what this coding challenge is. And then the gentleman, Jonathan and Adam, will explain their thought process and show us how to make it happen.
On the spot.
On the spot.
So this particular challenge sort of came about because, as you know, the holiday seasons are upon us. And I was involved in a very elaborate family group texting conversation the other day where people were like, okay, we've got all these grandchildren in the family and we're going to have to do some drawing names because there's so many of them. We don't want to buy gifts for everybody, so we're going to do a drawing name thing. So people were trying to find out ideas for doing it. And one person suggests, hey, let's draw them out of a hat. And then I'll just sort them. And I'm like, well, what about the siblings? They can't get each other's names. And it was just this whole thing. So we thought, wow, if we could pose this challenge to two people that are really expert problem solvers that we happen to know, Jonathan and Adam, maybe they could come up with a solution for this particular issue. So for the challenge, we've kind of put 3 different criterion or expectations for this particular generator that we're calling it, like a Secret Santa generator that we want you guys to code for us. And the first one, it's actually, we just need the Secret Santa generator. Then we want it to be where siblings cannot draw each other's names. So like Darryl and I pretend we are brother and sister, we're matching.
Yeah,
we're like
matching,
twins,
right? That's what siblings do. They match.
Yeah. That's what they do. They match each other all the time.
They match all the time.
All the time. Well, I don't want to draw Darryl's name. He doesn't want to draw mine. So it's got to be sophisticated enough where that doesn't happen.
Just kidding.
He doesn't want to buy me a gift. And then the third thing is we would like to have this element also in there where you could, whoever's name you drew, you could view like a wish list or just one item that they're interested in to give you an idea of what to buy for them. So Jonathan and Adam, based on that challenge, do you have any thoughts about how that could be pulled off in an easier way than just drawing names out of a hat and sorting?
Yeah, I think there's some ways we could make that easier. We have a small little plan here. I'll go ahead and share my screen. So before we get into the coding, we'll do a little explanation of what it's going to be. And whenever we get to the code part, it's going to be like a lot of stuff very quickly. And the actual stuff here that's important is not the actual like code, it's the logic, because you just have to think of like what the logic is. The coding, the words is just, you you pick that up along the way. You can look that up if you need to.
So is this something that you feel like Mr. Legaspi could do?
With some practice, yeah.
I do know my introduction to Python.
He's getting introduced to Python, so he'll probably be able to somewhat follow along what we're doing, and he might be able to replicate parts of it.
Awesome.
We're going to be using a few slightly advanced concepts just to compact the code down. But the things we're going to be using, they can be easily expanded out to basic Python functionality.
Okay, so what are we looking at right here? What is this?
So this right here. Oh, okay. Yeah.
So this is just like a quick overview of the problem at hand. So we have the wish list at the top. So let's say we have some names: John, Adam, Darryl, Elizabeth, and this is what they want. John wants a laptop. Adam wants a headset. Darryl wants a tennis racket. Elizabeth wants a painting.
I do want a tennis racket.
Really? Oh, well, lucky guess wrong. Okay.
Elizabeth needs a new painting. So we're not looking at the code right here. This is just
This is just me typing out just
like your notes. What are you typing it into, Jonathan? This looks like some voodoo magic from back in the 1970s or something. I mean, I was like flashbacks.
DOS run.
Exactly.
It's just a text document. I think for now, we're just going to ignore the siblings thing because we kind of didn't read it, and it makes it a lot more complicated, the sibling thing.
Mm-hmm.
Okay, I don't mind getting Elizabeth a gift.
I think we
can talk about how we might implement it. But there's some interesting like math problems that come up, I think, with the sibling problem, especially on like smaller situations that make it a little difficult. But this right here, what we're working in is it's a coding environment called Replit. So you can actually like follow along if you're watching this.
If you want to, you can go to repl.it/languages/Python.
Okay, so it's browser based. You just go to the website and then you can start coding right away.
You hit enter and it just like loads up, and you can. We added a new file, which is just a text file, so you can just type stuff. But if you want to, you can start typing here and hit run, and it plays the Python up here.
Okay, so on the right side, it plays whatever code or program.
This is the output right here.
Output. Okay, gotcha. I'm
so you can kind of test it right there in the environment to see if it's working and what you need to go back and kind of fix. Is that the idea?
Yeah, so you can, like, this is your Python program. You can type your code here, you hit play, and your output appears here.
Okay, cool.
Those of you guys who are listening, we're terribly sorry because a lot of this is very, very visual.
Oh, that's true.
On the left, there's a place for you to type your code. There's a green run button at the top. You click that, and on the right, it spits out some output. So our desired functionality is that you input a name. So let's say John. You pick a random person from the list, somebody else that's not my name. That's not John. So say we pick Darryl, and then tell me what Darryl wants. And so how are we going to go about doing that? So an interesting trick for doing this is basically put all the names in a list. So we take this John, Adam, Darryl, Elizabeth from this wish list. We make it into just a normal list of names, just a singular list of names. We shuffle the list. So we take all the elements, we shuffle them around. We have a shuffled list of names. So this is all random. And then we shift everything in the list back one. So you see, we shift it forward one. So, no.
Back one. Yeah, we shift it
back.
Back one. We shift them off by one. Yeah.
You shift it off by one. You can do it forward or back and it'll still work.
Okay.
And you just match. So like, see, I pushed the John, Darryl, Adam one over, and then Elizabeth I've taken from the end.
From the beginning and moved to the end.
Yeah, from the beginning and moved it to the end. So I've just shifted everything over. And then I just match the items in this first list to the items in the second list. So Elizabeth would go with John would go with Darryl would go with Adam would go with Elizabeth. And so the way I do it, now there's no overlap of names. Like we can't have John also called John, because if I was just saying for each item pick a random name, you might have some overlap where you get yourself, and with this approach, you make sure that each person gets somebody else in the list. And everybody has somebody.
Is there just one way of solving this problem?
There are lots of different ways.
When it comes to coding. Okay. So is this good practice for if like, you have a problem, is this good practice to kind of plan it out beforehand, or do you just go straight into the coding?
Well, it's absolutely good practice to plan it out beforehand, primarily because think about it, like if we were, there's multiple ways to do this. Instead of doing the shifting thing we could have something where for each person in the list, we randomly select a person, and if it matches them, then we randomly select a new person. But the thing is that it's less efficient than this, right? What we have here is because we're planning not only for something that works, but something that works well. And so that's what like the pre-planning stage is for. So we can think about different solutions. If we can, without having to type them all out, we can sort of visualize what we're going to do.
Okay.
So would you say with this particular challenge, before you just jump right into coming up with a solution right away, there is some brainstorming or some ideation or thinking of potential ways that would work best and more efficiently that you would go through, some type of process or train of thought before you would actually jump to the solution?
Yeah, so stuff like this, like writing all of this out, and like how Adam thought of that other solution, like this is stuff that like once you get into it, you go through your head, like you think of like 5 different possibilities, like you could do this or this or this. Oh, this wouldn't be good because this would be easier to do. So a lot of this you just kind of do in your head, and it just is like you don't think through like listing this out fully. You just kind of have a hazy idea of, oh, this will kind of work. And sometimes when you actually do it, it's like, oh, this doesn't work. I'm gonna have to start over. But most of the time you just kind of have a hazy idea of what's going on.
Gotcha.
So you guys have this as your planning phase, right? These are all your notes. And then have you already sort of put it into a place where you could run it, and could you show us how it would work? Have you gotten that far with it yet, or are you just
we've done little bits and pieces?
We're going to give you at least 5 minutes because we also want to talk to you about, other things as well.
All right. Are we ready?
We'll remind everyone the challenge. Again, they're setting up a secret Santa generator. We're going to stick with just random, right? You're going to randomly pair people together.
You have to randomly pair people together. It can't be yourself. And everybody has to have a pair.
All right, so we're going to take a look at what we want. And basically what we're going to start with is we're going to start with the data, right? We want to start with the names and what people want. That's the first thing we want to start with. And what we have here is we have this thing called a dictionary. So you can think about a dictionary as like a real dictionary with like words and definitions, right? So you have a list of words, and each word is paired with a definition. In this case, we have a list of names, and each name is paired with what they want. Okay, and so we have this is all stored in a variable called wish list. So wish list is basically has names and what the person wants. And so you can see here on line 9, Jonathan is printing out wish list, and he's looking for what Elizabeth wants. So this is like akin to like opening up a dictionary and saying, okay, like the word is paper, and you go to paper and you see what the definition is. So in this case, we're looking at the wish list, and we're looking at the name Elizabeth. We're seeing, hey, what does Elizabeth pair with? What does Elizabeth want? All right. And at the very top, we're importing random. That's just a Python library. It's like pre-written code that allows us to get random numbers and stuff really easily. All right. So now on line 15, we're getting a new variable called names, and that's wishlist.keys. So keys are all of the terms in the dictionary. So in this case, it'd be, or in this case, it's a name, right? So John, Adam, Darryl, and Elizabeth. So it gives us a list of just the names. And a list is like a fancy word in Python for just like a simple list. You can think about it as like a shopping list or something, where it's just a list of keys. And now you see that Jonathan wants to shuffle a list of objects, but he doesn't remember how to off the top of his head, so we're going to look it up, which is a thing that you always do in programming. And in this case, you just type shuffle in, and you put what do you want to shuffle in there.
3 minutes left.
Yeah.
Doing good. I'm learning.
So right here on line 16, this is basically saying, hey, you want to shuffle a list of names that have right there. And 5 right here is a seed. So that means that it'll randomly shuffle in the same way every time. So even though it's random, it'll give us the same results. So that way we can use it for testing. Nice and easy right there. And of course, we're just printing out the names. So right here.
Doing good. You're about halfway there.
Print Yeah, so now we have random names equals this, and then we're shuffling the random names. And now we have this thing right here. This is a little complicated, but we'll break it down a little bit. We'll focus on this part right here. So for I in range random names, so random names is the list of names that have been randomized. Range simply gives us the length of that, and then, or it gives us essentially, it gives us like a range from 0 to however long the list is. And then for I in that, so for every, essentially, like, you have a list of randomized names, and then for every number of like randomized names. So if you have 4 randomized names, you have like for the first name, second name, third name, fourth name, and yeah, just the fourth name, nothing else. Right there. What we're going to do is we're going to we're going to make a new shifted array from the position to the right of that. So like, let's say we want to, like, we have Jonathan, right? Or let's say, assume this is our randomized array right here, but it's not randomized yet. So we have Jonathan, and we're going to essentially point to Adam, right? And then we're going to have Adam will point to Darryl, and Darryl will point to Elizabeth, and Elizabeth points back to the beginning. That's what this modulus random name, the length of random names is for. And then we're going to combine.
Adam, do you know what this error is?
Which error?
Wait, we don't.
Oh, this error. Oh.
Hold on, that's.
Essentially, this is making a shift to the array that's like pointing, it's shifting everything over so that way we can point the things correctly. On line 20, we're combining the original random names and the shifted random names. And so we're linking them together into a dictionary. So yeah, it looks something like this wish list we have up here. Does this still not work?
List object cannot be interpreted as list object cannot be interpreted as an integer. Oh, range random names. It should be len random names.
Oh, that's why. Yeah. Okay.
Ta-da!
There we go. Okay, so now John matches with Adam, Adam matches with Elizabeth, Elizabeth matches with Darryl, Darryl matches with John. And so now we can write a little function that says.
Yeah, and you notice here that the names are they're randomized. They don't really seem randomized because there's only 4 people, but like John points to me, Adam, and then I point to Elizabeth, and Elizabeth points to Darryl, then Darryl points back to John, right there. So now that's pairing people up. We've managed to pair people up already, and now we're making a method called getSanta. Okay, so this is what the procedural decomposition. We're pushing this to a part of the program because it's its own confined piece of code. Essentially, the partner, we're going to get someone's. So the method getSanta takes in a name. Right? We give it a name like Adam, and then right here on line 25, we're saying partner equals pairs and name. So this is similar to what we had on line 12 right here, where we're looking in the pairs dictionary, which pairs people with who they're giving a gift to, and we're essentially saying, hey, look up name, and then that'll be, and it's returning the partner, and that's going to be stored in the variable right there. Jonathan, should this be in quotation marks?
Like 30 people are typing at once.
Yeah,
it's so fast.
And then, yeah, so now we're getting the gift for what the partner wants, right? So we're saying, hey, we're gonna look in the original wish list thing, put in whatever the partner is, like say the partner is Elizabeth, and we're saying, okay, Elizabeth, what's a painting? We're storing that in a variable called gift. So now we're doing some print statements here. We're saying, hey, person, your partner is, well, whoever the partner is, and get them and whatever the gift is.
There we go. Yeah. There we go.
Hey, Adam, your partner's Elizabeth, get them a painting.
Oh my gosh. Okay.
That's pretty phenomenal. So I have a question, all right? So I really don't know. I'm very interested in programming and all of that, computational thinking, obviously, because that's incorporated into other aspects like Darryl alluded to earlier. But why should this matter at all to educators right now? Why should they even care if students know how to code? Whether or not the educators, the teachers know how to do it themselves, why should they even care if it is a potential opportunity for the students in their class? How could it benefit students to be able to play with this kind of thing? Or
yeah, because like right now, this is a huge push in education. You have like Hour of Code, which is which is in December, right?
Yeah, it's coming
December.
up. It's
coming up.
Computer Science Week is what it's actually called. And then there's an hour of code where kids can just go in there and kind of play and learn how to do it.
Right. But you see it, I mean, I don't know about you, Elizabeth, but I see it a lot in elementary schools and middle schools, and it kind of fizzles out in high school. I don't know if it's because it's too complicated or they don't want to do those, other, I guess they find them kind of childish, those coding. I don't know. But I guess that's a good question to Jonathan and Adam. Like, why, especially in the high school, since you guys are in high school, why is it important to kind of dabble in stuff like this? And is it too late? Like, let's say if you've never touched it in elementary school or middle school, and what are your thoughts on that?
So I guess one reason to study this stuff is because it's just fun. I mean, like it's kind of annoying when you have errors, of course, like we had earlier. We had that error. We couldn't figure out what it was. That gets annoying. And computer science isn't for everybody, right? Because I don't think everybody that goes through Hour of Code or whatever should go into computer science and become a computer scientist. It's kind of it's a bit of an annoying profession, trying to debug this and debug that. What's really important is just the logic, and the logic part of it is just kind of fun. Just thinking of solutions. They're just little puzzles. And the soft skills are involved in lots of other different areas. One thing I've gotten really, really good at is Googling. Like you just saw, I Googled this in like 2 seconds.
Overstack.
Like I did this, shuffle list Python, and then I can click, and then I find out how to do it. This is a different website, but like I still found out how to do it. And like I can Google so many things so quickly. And a lot of computer science, I say computer science, but a lot of, let's say coding. A lot of coding is just looking up things you don't know and trying to figure out what it does and trying to incorporate it into your own project. And it really helps you learn that.
So it's really knowing what to search. Yeah.
Yeah, and it's really good thinking about the soft skills that a lot of employers really want their employees to have, that problem solving, that critical thinking, and thinking outside the box, and take an initiative to do that without waiting for someone else to do it for them. This really helps people to sharpen those skills and to gain more skills doing that, right? But why, like you guys are about to graduate high school, how do you see using these skills in whatever you're going to do? And even if you weren't going to go into some type of computer science or coding type of field,
engineering,
is there a reason why students who wouldn't necessarily do that type of work understand or have experience playing with this? Is it going to help them in other fields?
It undoubtedly has a big impact, especially as we move to a more data-driven world. So there are things like, just bring up a recent example, like the election results, right? And a lot of the data is made public, and being able, like if someone makes a claim about the validity of election results, being able to take that data and process it for yourself and see what's actually going on there is incredibly important, right? Because that's essentially what we did. We took data about who people are and what they want for Christmas, and we processed it to pair people up to get people a gift, right? And so it's a similar kind of situation where you have data, in this case like election data, and you're looking through it to see how the data comes out. And even if like it's not something that you're doing for a job, it's a nice useful skill to have for yourself. So it's like being able to conduct your own research in any topic, right? It's always good to be able to conduct your own due diligence on something.
I didn't really think of it, but I guess what we really did for the Secret Santa generator, we created a data processing pipeline. We take in a dictionary of data. I mean, you can get that data from wherever. We typed it because it was easier, but if you have a million rows, you can't just type it. You import it from a file. We took a dictionary of data and we did some transformations to it. We took for loops and we added them to lists and shuffled things. And then at the end, we have a nice little function where you can ask a question of the data and get a nice response. And so it's data cleaning. That's what we just did.
So you could use it for something else besides Secret Santa. That's what you're saying.
Like not this specific program, but the skills that you learn from doing this, the skills to be able to process through lots of data are incredibly useful.
But just watching you guys go through the process, I mean, it is like you said, a puzzle. And once you solve it, it's exciting. And I actually understood some of it because I took an introduction to Python course, and it's like, I feel great about it. I understand about half of this. And then you went to overstack, and then I got confused.
Yeah, so like you saw me import random, right? There's lots of different. Python is really good because you can import stuff from everywhere. There's lots of different data science packages, especially that you can. When I say package, I mean that all that means is code somebody else wrote, and I can just hit import, and then their thing.
Use somebody else's code.
Yeah, and so like I didn't have to write my own thing to get random numbers. Like that would be crazy. Yeah. People can do that. Adam would probably be interested in how that works.
There's a whole lot of math and science behind it.
Adam really likes the math behind it.
So would you recommend for those who want to start off coding to start with Python? Is that a good language to start in?
Yes.
So it depends on what you want to do with programming. So there's a few different tracks. I think there's three main pathways here. There is the traditional computer science, which is like it's very intensive in math. So if you like math, that's the route you want to go. And you might want to start with a language like C++ or something. But if you're going to use it for data processing, which is what a lot of people want to use it for, then you should definitely go with Python route. Or if you want to do it as like a hobby, right? Like it's like you're doing programming as a hobbyist, or you're working on some small projects or something. Or if you're like a teacher in the classroom, right? Then Python's a really good thing to start out with. And even work with, because it's incredibly versatile. It's really easy to use in terms of like the syntax. There's not a lot of overhead. You just sort of type things and they just work magically.
Yeah.
Computer Science Week was December the 7th through the 13th. And I know if you go to that website for Computer Science Week, you can find a lot of different activities on there to kind of use in the classroom if you're an educator wanting to try to let students have some choice and experimenting with some of these things on their own. And code.org is another website where students can go in and play around with some cool things. They can create little avatars that dance and make their own little dance party just to kind of get started and get playing with it. Because I bet Adam and Jonathan, if we asked you, the younger you start, is it better?
Not necessarily. I mean, it's always good to get an introduction to like being able to use computers, like being well versed in using computers. But there's a lot of in computer science. There's a lot of concepts that are a little hard to grasp at a young age. So there's things like the list comprehension thing we went through. If you have a for loop and you're doing something through it, it's a lot of stuff happening at once. It's a little hard to grasp at a young age. So there's a lot of concepts that I like. Or I think this is true for Jonathan too. Like in middle school, we looked at them, we're like, we don't understand any of this. And then a few years later, come back to the same thing. Oh, it's simple and it just clicks right there.
So I guess everybody has. Yeah, I was about to just talk about that
even because of block coding, like whenever I did my course, my intro to Python or computer science, we did block coding for 2 weeks. And then
everybody has a different path towards getting here. Like Adam's path was probably he picked up like his dad gave him some Java textbooks in middle school. He read the first couple of pages of them and he knew a little bit of Java. Mm-hmm. For me, it was in middle school, the EV3 coding. Most people, it's just like move forward, move back. And so like, okay, that kind of coding. So I'm trying to use the words coding and computer science. I'm using them interchangeably, but I'm trying not to because
that's a hot topic right there. Yeah.
Mm-hmm.
Yeah. Computer science is like if you're like almost like what we just did where we made it's like a logic puzzle, right? You've got it's closely tied to math, and there's some like it's the actual thing that's important is not like the things that you're typing. It's just the code itself. Things like web design, web development, that's more of like coding because like it's not really like a logical type. It's not focused on the logic. It's more of focused on
the art, the beauty, making it look nice, right?
Which is nice. It's just, they're just different things. So like for the EV3, right? If I'm making code that moves the robot, if I say move the robot forward, make the robot turn left, make the robot turn right, make the robot go back, right? That's not really computer science, because all that's doing is it's just telling the robot do this, then do that, then do this. If I wanted to take that to computer science level type stuff, maybe I would say something like make the robot follow a line on the ground. So I have a color sensor, and if it detects black, then it moves left, and then it moves right. And so over time, it makes this like pathfinding robot. So I think the logic of it is important. So like sometimes I look at like I understand it's kind of hard to do computer science stuff and integrate that at a young age. And sometimes I see like the CS First stuff or the code.org stuff, and some of it is just like, yeah, that kind of works. But like a lot of it is like you make an avatar that dances. It's mainly you're coding just so that it can move this or move that. There's no like deep logic that's going into it. And you can do the logic without the coding, or you can do the coding without the logic. And computer science is whenever you put those two things together.
That's a really good point.
Yeah.
I've never really thought about like the difference between those, Jonathan. I think you explained that very, very well, because like you said, making the avatar dance, there's not a whole lot of logic with that. You're just kind of doing some different directions or pushing some buttons or whatever to make that happen. But it can be inspirational. So it might kind of hook and get them interested. And then some kids are going to actually start thinking, I wonder how that works. Like,
yeah, and that's how I got into the EV3 stuff. Like you start with the blocks, then you go on to, more complicated things. But
if you don't have the exposure to it, then like if no one ever showed you anything to get you inspired or gave you exposure to play with those things, you might not have the idea as quick maybe as you would have had you not had that stimulus. So I think exposing kids at younger ages is always good, because some of them are going to jump on it. Some of them are going to be like, whatever, this is just like a game. But there are going to be others that are going to be like, I want to figure this out. And
the important thing is exposing kids, maybe not incorporating it to the logic as well. Because I think you can have a program where people do the avatar moving around, and you can have 100 kids go through the program and never think about, doing it again. But like introducing the questions of like, maybe I can make the avatar move based on something else, or say something like, if I move the mouse up, then the avatar does this, and then if I do this, it's like thinking of more complicated ways to introduce logic.
Yeah.
Yeah, like problem solving, computational thinking into it, rather than just be like, avatar move, hand this way, move this way, and waves.
John, you mentioned introducing the concepts to younger children. I want you guys to talk about it, Adam specifically. Talk about the programs you have created or you initiated at Summer Creek High School, and how it's trickled down to the middle school. Can you tell us more about the club you all started?
I can go ahead and talk about the ideation of it. I think Adam probably can talk better about the actual stuff. So we were trying to do this UIL computer science test. And we kind of, we were hoping that in high school we would get more resources for computer science, but there's a lot of reasons why it's harder to get computer science resources in high schools. I think the most important is probably the fact that the starting salary in computer science is probably double that of being a teacher. So if you're deciding, am I going to be a teacher or am I going into computer science? It's like one of those things like engineering or like hard maths, very advanced maths or computer science.
I get that.
It's hard to find computer science teachers. There's a big shortage of computer science teachers. Adam here really wants to be a teacher. So yay world.
Yeah, is that true, Adam?
It's possibly true, maybe.
Okay.
I may or may not have checked the teacher certification box on my college application.
Okay. Because we inspired you.
Yes.
Yeah, definitely. It was you. It was you who inspired him.
Okay.
You specifically.
Let me.
I'm talking to both. So, like, for if Miss King, you're hearing this, it's you specifically. Mr. Legaspi, it's you specifically. Okay.
We are not competitive at all. So.
Oh my gosh, it's great.
So, well, we started Hack Club. So, Hack Club is we're part of a global network of Hack Clubs all around the world. It's high school student-led high school coding clubs. So every week on Tuesdays, we meet after school and we make little projects. And we try to, it's focused on project-based learning, which has its benefits and its drawbacks. And we can talk more about that if you want us to. And so we do that every week, and we try to teach coding through that. And we expanded to the middle school at some point. and the middle schoolers kind of ate it up.
Explained how like we're trying to create a community of programmers, right? Because there are schools with like millions and millions of dollars that they've they just get like tons and tons of funding from like donors and rich alumni and stuff like that. And unfortunately, not all schools have the benefit of that. Not all schools have the benefit of being able to throw like $20 million at the problem and hopefully figure it out. And so what we're trying to do, and what Hackle's trying to do, is foster a network of programming and coding communities at each school to help account for that massive gap right there.
I love that this organization or company or whatever you want to call it exists, because it's free for you guys to use those resources, right? And then you just kind of share that out with the different students on the campuses, and it has the different activities built in for them to start to code. And Darryl and I have both had the pleasure of coming out and visiting your schools when you've been doing Hack Club with these students and kind of seeing the engagement and the interactivity that's happening there, which is super awesome that kids would stay after school on any given day to do something like this. And we even invited you, I remember this one specifically because we invited you to come and speak to a group of teachers that we work with throughout the school district. And you guys spoke to them about what you were doing. You brought them free stickers, Hack Club stickers that they could put on their laptops. And they were so excited about the free stickers. Yeah. Then you got up there and blew their minds by running this piece of code that probably to you guys was so simple and like minuscule. It was so much as like changing the color of some text on the screen and then running it.
I remember that.
And people were just like minds blown emoji, because they were like, wow, that is so cool. And they thought you guys were child geniuses, which we think that you are as well. But I mean, it's just amazing what you're doing. And you are influencers, you're influencing students, but you're influencing teachers also. And I'm so thankful. I know Darryl is too. Really thankful that I've had the chance to meet you guys, and y'all have presented with us at like actual state conferences.
That's right.
Before.
That's right.
I mean, all of the things you have done in your high school, middle school careers is quite amazing. Is there anything else? I mean, y'all started something else. Did they start anything else? They got Hack Club going on. What other things have you been doing? You talked about teaching earlier. That reminded me of.
You do online courses, don't you?
Yeah, because one single online course.
That's okay.
But one of the big problems with Hack Club is that, or at least what we see right now is that a lot of students are afraid of programming because they have no foundation in programming. So versus a lot of other clubs and organizations with robotics, right? If you want to join robotics, pretty much everyone can pick up a hammer. Pretty much everyone can contribute somehow to the robot, even without any robotic experience. Right? There's it's not that hard to pick up a saw and cut a piece of wood along a straight line right there. Versus programming, there's a bit of a big bump at the beginning, and it's a very intimidating bump, especially if you don't know anything about programming. And so we were looking at this over the summer, and we were thinking, how do we address this? And so we decided to put together a one semester course. So it's sort of like a crash course to programming, and it's kind of the similar style to what would be your first semester introduction to programming course at a university or something if you're majoring in computer science. And so the goal of this is to help guide students along that initial first path, so that way at the end of the course they have programming skills, so that way they can go out and create new things right there. And so we launched an online course called CS 101, and we would meet 3 times a week in the evenings to talk about programming to the students.
And can anyone? Is it too late to sign up? Could any
it's almost done.
Almost done. Are you going to start again?
No, we have some plans for. We're starting plans for what we're going to do next year. We've got some changes we want to make.
So then how would people know where to sign up? You want to give them information right now?
Precoding.com. You can go there.
Precoding.com.
We'll probably post any changes that we make there, because that's the main website, and you'll be able to see. We're currently talking through what we want to do for next year to get more people in Hack Club. And I guess this is touching what I was talking about earlier, how project-based learning has its advantages and disadvantages. The advantages are you can walk in, you can read this thing. We have the Hack Club provides these things called workshops, which are basically projects in a box. It's like a website. You go to the website. It's like a step-by-step tutorial. this is what you do, this is what you do, this is what you do. And at the end, you have a website where you can say a color and it changes the website's color to the color that you said. And it's kind of amazing. The only thing is, if you know nothing about coding and you do that, a lot of it is just copying and pasting things. And
which you got the Overstack. You just copied and pasted.
Yeah, you just copy and paste the things from Overstack and you put it in a list, and it will work. You hit play, it works. This is what I did in 7th grade when you were talking about the whole thing with like, the very complicated forms thing.
The form.
I didn't really know too much about what was going on. I can copy and paste and cobble together different things. The way you start is with trial and error. Like you change a number here and you say, that, like if I was doing this with Google Sheets, like I was doing with the thing earlier, you change a number here and you're like, so that corresponds to the row number and this corresponds to the column number. You just change numbers, try to figure out what goes where. But a lot of times it's better to get some kind of foundation before you start going into projects. Like you can start a math club at a school, and people generally know what math is. But if you try to get somebody to start doing, some basic computer science stuff, I mean, what is a variable? What's a for loop? What's an if statement? Like all of these things are a bit foreign. It's not like people don't know what those things are. So there's like you need some kind of foundation before you start making projects, so that you can make projects that make sense.
Do you know what I also think too is helpful with the people that are not really that great at coding, who might not even know if they want to, is to kind of see the end product first, right? Mm-hmm. See how it works. Wow, that was cool. Like, because when you guys did that text, that color, the texting, you showed us that, and we're like, oh my gosh, how did you do that? It seems too complicated. And then you're like, it really wasn't that complicated. And then you're able to like break it down into those smaller parts and those smaller chunks, so that you can see you can be successful at doing this, which makes you kind of hungry to want to know and want to do more. So I love the idea of showing them an example of what they could, or letting them say, hey, like we brought you that Secret Santa challenge problem. Like we need a way to make this happen. Learning. Yeah.
You can say, that's the thing I'm working towards making that thing. Which is, I guess, like it's one of the best ways you can learn computer science is if you're working towards a goal. Like if I have some base knowledge, I know what the basics are. And I want to make I saw somebody made this thing, and I want to work towards making that. And you just kind of learn whatever you have to learn to get there. You don't spend like the whole time of your focus isn't spent on learning, it's spent on building, and you just learn along the way of building.
Yeah. I love that.
That really is like the key part of computer science, is learning how to make things. So it's that people say like the programmer's mindset is like everyone can think of a great idea, but like being able to take what you know and somehow make that thing possible is what makes like
it's powerful
with computer science. Computer science right there. It's also why they pay computer scientists so much money. Because that step, it seems easy. Like you could be like
copy paste from Stack Overflow. It's about knowing what things to paste from Overstack and in what order,
and what questions to ask.
What to search on Google. Like how do I even phrase the question? What are initial problems I have to solve first before I can solve the final
Mr. Lick asked me, what are you going to do when these two guys graduate from high school? Because they are seniors and they're going to be, what are we going to do?
I know. I don't know what UIL computer science is going to look like. That's why I took the liberty of learning coding myself. I'm trying to get certified to be a computer science teacher in high school. That's what this program is doing. Yeah. Oh. So there's an incentive for me. If I do pass the test, I get a pretty big stipend. So
and if Adam gets his teacher certification, he may come back and work for the school too.
There you go. Perfect. So
I don't know.
I take the test.
Adam can probably do better elsewhere.
Oh no. Well, okay. So what are your plans then? What are the next steps? You guys are going to graduate this year. What are your thoughts?
Well, obviously we're going off to college, right? But
do y'all know where you want to go? Like I know, Jonathan, you wanted MIT was your stretch goal, right?
It's the dream, but it's very expensive. So,
yes.
Adam, what about you? Say Adam, where?
MIT is also the dream school.
Okay.
Chances of getting in fairly low. So the actual school.
You know what? You show them this podcast, and it's done.
And they'll be like, "You're extra not in now."
But we will take Darryl and Elizabeth.
UT UT
is like our I think it's like a good school because it's one of the top computer science schools in the country. It's somewhere in the top 10. And
that's why Legaspi
you get in-state tuition.
Yeah. Well, the program that I'm going through right now is through the UT Computer Science program. So I know people there. If I can throw in your names to, you know what I'll do?
Yeah, Turing Scholar.
When this podcast is over, I will share it with that group. I think some of them they're part of they're part of the teaching, the computer science teaching program.
Quick, Adam, let's get some buzzwords, some computer science buzzwords, so that they know what we're talking about.
You're for sure. You're already top 5%, so you're in. But now you want to.
Well, not guaranteed the program though, right?
Yeah, I think you guys are in. I think you guys don't have to worry about that. But well, man, this is great. That was a lot of information that I even learned through the process of you programming. I'm like, I can actually finally follow you guys as you explain the code. And I know that when you did your hack clubs, like, what's going on? What does that even mean? But now I understand.
I don't know that I can follow it, but I can follow you guys wherever you go.
Well, now it's time for you to take the intro to computer science thing that Darryl's
Maybe
doing.
I need to do that. I'll just follow the balloons like Adam did.
Yeah, it's a great program. But we hope to talk to you guys in the future again, like whenever you get to your university and you're doing great things there. We'll for sure schedule.
They know they're not going to get rid of us. We've been on their tails for like a long time.
I know. We're gonna live vicariously through you guys as you continue doing amazing things. So you said creekcoding.com is how to
make sure that's the website. Goes to the right place.
The website is still
how do people follow you? Do you
have a
website? Okay, so creekcoding.com is to reach out to these guys and see what they're doing if they do a course in the future. But man, a lot of great information for our viewers out there. If you're listening on the podcast, you might find us on YouTube video. The what they're sharing with us through, was it Replit you were using?
Yeah, we'll give you the link.
And we'll send you guys. Yeah.
Stuff. Awesome.
Yeah, and it'll be up on the screen too for them to see if they're watching on YouTube, or check out the Flippin' Good Tech website too for all of the good information about this, and also the links to the audio and the video versions.
All righty. Well, I think that ends this episode. A lot of good information. You want to throw something in? Yeah.
I do have to mention on the Creek Coding website, even though we're still updating the stuff on what's happening next semester, but there is a nice fancy donation button in the upper right hand corner.
Yes.
If you want to click there, you want to donate
$10, $100, $1,000.
So crowdsourcing going on in this podcast.
Amazing. Yes. All donations are fully tax deductible.
We don't we don't get any cut in that. So
Hack Club is a registered 501c3. So give all your money.
Okay.
And I love too. I want to throw this out there before we leave. Is that we are also nonprofit at Flippin' Good Tech, but our little podcasting that we do started as a passion project, and I feel like what you guys do on the side is obviously you're very passionate about it. So I love when your passion can overflow into your work and your livelihood, and we wish you guys all the best and all the millions of dollars that you're going to make one day. Do not forget your good friends, Elizabeth and Darryl, at our small little podcast that made you famous. Flipping Good. Okay.
Very famous.
All righty, ConnectED Techers. That's all we have for season 3, episode 1. Thanks for taking the time to watch us. Follow us at Flippin' Good Tech, and follow these guys at creekcoding.com. They have lots to share. Signing off. You all have a wonderful day. Peace.